Alright. Yeah. This is going to be page 240. Number 8. It says y is equal to 1 minus 2x squared. Then you're going to get x. You're going to be told x equals 0. Delta x is equal to dx, which is equal to negative 0.01. And it's going to say evaluate and compare the differential of y and delta y. So start with the easy one, the differential of y. So we're starting with dy. So what's the derivative? Because we're going to start with the derivative of this times dx. Alright, negative 4x times dx. Now what is, x is 0, right? So this is going to be equal to negative 4 times 0 times negative 0.01. What are you going to get? 0. So my dy is 0. So it's saying that my approximate change in y is nothing. Do you think that to be true? Nah, it's probably going to change a little bit. Maybe not a ton, but a little bit. Yeah, that's the Italian way of doing it. Alright, this is going to be f of x plus delta x minus f of x. Alright, so I need 1 minus 2 times x plus delta x quantity squared. So basically what this says is wherever you see x, replace with x plus delta x, which is what I did. Then minus 1 minus 2x, put that in parentheses, 1 minus 2x squared. Alright, so I'm going to jump over to here, and I'm going to do a little work on the side. I know x plus delta x quantity squared is equal to x squared plus 2x delta x plus delta x squared. Now I'm going to take this and multiply it by negative 2, get negative 2x squared minus 4x delta x minus 2 delta x squared. Yeah. I expanded this. A plus b quantity squared is a squared plus 2ab plus b squared. Nope. Well, technically, yes. Well, yeah, that one's the a plus b quantity squared, which you should have learned in Algebra 1. A squared plus 2ab plus b squared. I mean, that's one that should be burned into your noggins. When you get to the cubics, then you're like, okay, I gotta look at Pascal's triangle. Alright, so now I'm going to take this and plug it back in for this part right here. So I'll get 1 minus, or I'll get 1, and then since I already multiplied the negative 2 by everything, I'll get minus 2x squared minus 4x delta x minus 2 delta x squared. And then I'm going to get minus 1 from here. Do you agree? And then plus 2x squared. And this whole thing right here is f of x plus delta x minus f of x. So I got everything you need. It sure is. Now, can I divide anything or subtract anything out? Yep. the 2x squared, there's positive 1, there's a negative, well, there's negative 1 there. Sorry. That one's staying. This one guy that I highlighted. The negative 1 and the 1 is gone, and the 2x squared and the negative 2x are gone. No. Because when I multiply it by 2, negative 2 times all that, that's what I got from here. So I can replace this entire part right here with this, which is what I was able to do. What first one?
The first one in the equation. You cross it out, right? Two ones.
Yeah, because that's a 1, and that's a negative 1. Because I mis-highlighted something. That's why I have a frowny face by it, because I messed it up. So I have negative 4x delta x minus 2 delta x quantity squared. Alright, so what's my target x? 0, isn't it? Well, if I have 4 times 0 times that, all this stuff right here is going to be equal to what? 0. Thank goodness. So I'm going to have 2 times, now my delta x, negative 0.01, I need to square that. So I got negative 2 times negative 0.01 squared. This is equal to 0.0002. So this tells me this is the exact change in y. And if I move this back over to here, zooming out just a little bit, because it didn't come out negative. It should have. Because the negative went, my calculator screwed it up. So it should be negative 0.00002. So no, they get out crotchety. No, I usually wasn't in class. I believe in brutal honesty. Now, this is the exact change in y. This is the close to change in y. Now, what was the original answer? When x is 0, what did I get? Now, here's the test. It's 1 minus x, or 2x squared, right? When x equals 0. So this whole part goes away, right? And so I get y is equal to 1. Now, when I change it to negative 0.99, that's what we're really doing here, aren't we? I should expect to see y is equal to 1 minus 0.0002. Because my change in x is this. So I'm going from x equal, I'm going from x equals 0, then I'm subtracting 0.01, so x is going to be equal to negative 0.99. That's the whole idea. That delta x and that dx is your change in x. So what we're doing is, we're basically taking this whole idea of local linearity and the linear approximation idea and saying, alright, if we just move a smidge to one side, I can calculate an approximate change, which is 0. Would you agree that approximately it changed nothing? Yeah, because there's tenths, hundredths, thousandths, 10,000ths. It only moved a little bit. However, as x went to 0.99, if we go back to the original equation, I'm hoping to goodness that this is going to end up being 0.9998. And since I have the four-dory luck, it's not going to work. So let's try. Mhm. Yeah. That might make my life a little bit easier. Alright, so if I go into the original equation, this ends up being 1 minus that, which would end up being 0.9998. That's what I should still expect to see. So let's plug in what we got. 1 minus 2 times negative 0.01 squared. Is that correct? Yeah, because I had already started it. 1 minus 2 times negative 0.01 quantity squared. My negative's on the outside. Hey! Y is equal to 0.9998. So it took us a while to get there, because it's 6th hour and the brain is fried. 6th hour on Friday, the brain is fried. But this was the exact answer when y was evaluated at x was equal to negative 0.01. Yep. That's a fancy way of writing it. Yep. We have our moments. Or they have their moments. I'm not a mathematician. I just teach math. But look at what we had. We were able to actually, delta y got us the exact value, didn't it? Delta x, or dy, the differential said, hey, the difference is 0. You're just going to get 1 minus 0, which is 1. Now which one, this is my approximation. That got me my exact value because I was able to go 1 minus 0.0002, get 0.9998, and that was the exact value of the function. So that's what delta y and dy give you. Dy gives you the approximate difference. Delta y gives you the exact difference. So it's a way to figure out exactly what it's going to be. And so when it says evaluate it, we evaluated it. Compare it, then you could say dy, hold on one second, dy That's how you evaluate them. And remember, this is from x equals 0 to x equals negative 0.01. And that'll get you, that's kind of how you compare those two. What was that? It's like,
It's dark on one side.
sorry. There's some limitations to the technology that I have here. I'll figure it out. But it's okay. You can still see it, right? Deal with it. You guys will be okay. I can't help the technology.